Okay, so I thought we'd take a quick minute and just talk a little bit more about traversing lists, specifically just so you could see graphically, or visually, I should say, how list traversals work, right? I kind of threw some code at you that kind of described how you would traverse a list, but we never really saw it visually. So I thought we'd go ahead and take this little bit of time just to do that. Right, so in our print function, we have a perfect example of traversing a list from start to finish. Right, we basically say node start w equals head, while w does not equal null, print off the value, and w equals w arrow next, right? So in our Zybook over here, we have basically the exact same code just in pseudocode form, which traverses the list and it also visually shows us what's going on. Right, so if we take a look at it, right, we're basically saying go ahead and traverse this list. So the first thing we do is they set cur node equal to head and print off its value, right, which is the exact same as when we do node start w equals head. And then we too go into a loop, right, where their while loop says while cur node is not 0, our while loop is while w does not equal null. These are both the exact same thing. Right, so we have our cur node or w, and then we print off its value, and then the next thing we say is cur node equals cur node arrow next, which when we look at that, that just goes ahead, goes to our next pointer, tells us where cur node should be next, and we do the same process all over again, right? So we print off the value found there, and then we go ahead and we move on to the next pointer, right? So we just basically have this one pointer that just walks the list one at a time until we get to the end, which is designated by null or in the Zybook 0 in their pseudocode, and we just keep going over and over and over again in this while loop until we finally hit the end of the list, at which point we just stop. Right, so hopefully that's all pretty straightforward, right? If you need more time with it, just keep on playing with the visualization, draw it out, ask me questions, etc. Right? Because overall, it's a pretty straightforward process. And like I had mentioned before, what you put in the while statement matters, especially when you're traversing a list. Right? If we would say while w arrow next does not equal null, that would stop us basically one before the end of the list. And it gets even a little weirder once you start doing like node arrow next, or trying to chain things along those lines. That makes things a little harder to predict what will happen as well. I would not recommend doing things like this that I mentioned before. Next arrow next, because then you can run into situations where there may not be a next node, or that memory may not exist, and you'll end up with a seg fault, etc. So try to avoid things like that and just kind of stay either at the w for the specific pointer or the one pointer directly following it. Okay, just be aware of that. I also thought that we could take a minute and I would show you another way to kind of traverse a list, which is doing the exact same thing, just in a different method. And that method basically being recursively. All right, so far our current list traversal with the pseudocode and our code just is in a while loop, and it just goes to the next one, to the next one, to the next one, and it's pretty simple and pretty straightforward. But I thought we could go ahead and take a look at what this would look like recursively as well. All right, just so you can see it and start to get your mind thinking in recursion a little bit, because that's going to play a pretty big part in our second major topic of the class. Okay, so to declare a recursive print function, what I'm going to do is I'm actually going to declare two functions. I'm going to declare one function that the user calls to kind of kickstart the recursion, and then I'm going to declare a private function which actually does all of the recursive things for us. I found it just kind of makes it easier than trying to manage one master function, especially with how we have our class set up right now. It could be done in one function, but we'd have to change a few things to make it work out. So the first thing I'm going to do is I'm going to create our public function called print_rec for recursive. And then in our private section, what I'm going to do is I'm going to declare another function called print_helper. And this is going to take a node's a pointer to a node called cur_node, right? And that's the current node we're going to be working with. All right, so the first function we can go ahead and define is void list print rec. And all this function is going to do is it's just going to basically call print helper, and it's going to tell print helper where the recursions should start. And in our case, we want to start at our head node of our list, right? Because we want to print from start to end. So we're going to call print helper and pass it head. And then after all of that, I'm just going to print a new line because I want to. All right, so now that we've defined the public facing function, which is just a wrapper for the actual function that's going to be doing all of the work, we can do, come on, Vim, you can do it. There we go. Void list print helper with our pointer parameter. And then all this function is going to do is the first thing, because remember in recursive functions, we need to make sure of a couple things. First, we need to make sure that we have a base case that actually stops the recursion. And then we have the actual steps that lead us up to that base case. So in our instance, our base case is basically if cur_node is equal to null pointer, meaning we've reached the end of the list or our list could have been empty to begin with, right? Then we could just go ahead and return from the function. Or we could flip our logic around, which is what I'm going to do. And I'm going to say if cur_node is, if cur_node is not null, then what we're going to want to do is we want to print out the value of the function, or not of the function, we want to print out the value of the node, right, which is just cur_node arrow val, and we're just going to put some spaces behind it for formatting purposes. And then after we do that, we would actually call our recursive function, right? So we're just going to do print helper, and we're going to say cur_node arrow next. And there we have it. That is our recursive function, all, 3 lines of actual code. I guess probably closer to 6 lines with the helper function, etc. But that is all there is to that recursive function. We are just going ahead and sending in the next node into the function. It prints it, send next node, next node, next node, etc. until we've reached the end, and then the recursion comes all the way back up. Now, I'm not saying this is the best recursive way to do it. This is just a recursive way, and I think a pretty good example of recursion, or at least a very simple example of recursion working. All right, so we can go to our file, or to our main function, and at the bottom, I'm just going to call print rec instead of the actual print function. So we can compile it, and we'll run it, and as you can see, everything printed out correctly. Again, both functions are doing the exact same thing. One's just doing it iteratively, the other is doing it recursively, right? Just to kind of get your brains kind of churning on recursion a little bit. All right, so that's all I was going to cover in this video. Just make sure if you have questions, let me know.